Okay, let's find speed of sound using definite integrals. At different altitudes on the Earth, in Earth's atmosphere, here we have the sound travels at different speeds. Those are speeds. All right? And the speed of sound, S of x, here we have equal. And it's measuring in meter per second. Speed of sound measured in speed at a meter per second. And this is the model of sound. So it's running with speed negative 4x plus 341 when altitude is greater or equal 0, less than 11.5. And then the speed is 295 meter per second when altitude is x is greater or equal 11.5, less than 22. 3/4 of x speed plus 278 and 5 when altitude x greater or equal 22 and less than 32, and so on. And here we have a graph. I put it on the graph so you can see. So this is speed of sound, and as you can see, depends on altitude. Okay, so let's begin integrating S of x over this interval are given. So, and those are broken the intervals we have here and speed accordingly. So what do we have? Let's write down. So definite integral S of x dx, and the minimum is 0, maximum is 11 over 5 here. So it's going to be from 0 to 11 over 5. Is equal integral from 0, 11 over 5 plus negative 4x plus 341 dx. This is going to be equal negative 2x squared plus 341x, and boundaries or limits between 0 and 11.5. I'm pretty sure you can plug in and you would get 3,657. Next, integral S of x dx, and limit is 11.5 till 22, and this is equal 11.5, 22, 295 dx. This is equal 295x, 11.5, and 22. This is going to be equal 3097.5. Next, integral. It's going to be between 22 and 32, right? Here. 22 and 32. Sx dx. That will be equal 22, 32. and the speed of integral on this, the speed of sound on this in this range, it's going to be 3/4 x plus 278.5. So 3/4 of x plus 278.5 dx, and this is going to be equal 3/8 x squared plus 278.5x between 22 and 32. So, and this is going to be equal 2,987.5. Just real quick to remind you how we calculate this, just in case if somebody forgot. 3/8, let's say, x is, first I'm plugging this 32. So 32 squared plus 278.5 times 32, and then minus in parentheses, so because when we open minus we will flip the sign, right? 3/8 times 22 squared plus 278.5 times 22. That's it. Once you solve it, you will get this result. Okay, moving to the limit between 22, 32 we did, between 32 and 50. Okay, 32 and 50, s of x dx, that is going to be equal 32 and 50, 3/2x plus 254.5 dx, and this is going to be equal 3/2x plus 254.5 x, and here we have on interval 32 and 50. Okay, let me put this in parentheses so nobody hesitated. We usually don't put it, but just in case, so if anybody hesitating that this limit 32 and 50 belongs to only one term, or no, it belongs to both terms, obviously, but I'm going to put in parentheses. It's never hurt to have additional safety. Okay, and this is gonna be equal 5,688. And lastly, we'll identify the integral between 50 and 80, s of x dx is equal integral between 50 and 80 negative 3/2x plus 404.5 dx, and this is equal negative 3/4x squared plus 404.5 x between 50 and 80 is equal 9,210. Now we are going to add all these results we got, starting from this one, this one, this one, this, and this. So what we're gonna get, so we're gonna get the lowest limit of all intervals is going to be from 0, and upper one is 80, right? S of x dx it's going to be equal 3,657 plus 3,097.5 plus 2,987.5 plus 5,688 and plus 9,210. Move here. And this is going to be equal, if you add them up, 24,640. So, from here, we can say the average speed of sound from an altitude of 0 kilometers all the way to altitude of 80 kilometers. Here we have is going to be, now let's remember the average. So how are we going to calculate the average? Let's write down, because we are figuring out the average, and its average is going to be one over 80 minus 0, remember, b minus 8, and integral from 0 to 80 s of x dx, which is going to be equal 1 over 80 integral between 0 and 80, 24,640, and that is going to be equal, since it's a constant, right? It's going to come out, and we are going to get average speed is equal 24,640 divided by 80, and this is equal 308 meter per second on the at the range of altitude between 0 and 80. Now, this is an average, and here we didn't count the temperature also, so don't take it that speed of sound, it's going to be only 300. It's going to be different at different degrees of temperature, okay? But here is example how to use definite integral in real life and figure out the average speed of the sound. I hope you enjoyed it, and I'll see you in next video. Okie dokie.